Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about problems on probability density function, problems on PDF. So, we have already discussed these problems that is based on probability density function. So, what is the formula for mean in probability density function? So that is integration over minus infinity to infinity x into f of x dx. So like that, for variance v of x equal to integration over minus infinity to infinity x square f of x dx minus mu square. So and standard deviation. So standard deviation means under root of variance. Under root of variance. That means under root of sigma square, that is sigma. So that means under root of variance means in here we have variance formula, that is integration over minus infinity to infinity x square f of x minus f of x dx minus mu square. Okay, so this is the formula for standard deviation. By using these formulas, these three formulas, we have to solve the problems. Those are probability density function problems. Okay. So, first we will discuss about what is integration of uv dx. So, integration of uv dx or integration of uv equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on. So, this is the formula for integration of uv dx or integration of uv. So, here u dash, u double dash, u triple dash and so on. These are differentiation or derivatives, and v1, v2, v3, v4 and so on. These are integrations. Okay. So next, first problem. So problems on probability density function. First problem. A continuous random variable has the following probability density function. So f of x equal to k into x e power minus lambda x, comma, x greater than or equal to 0, comma, lambda greater than 0 and 0 otherwise. Okay, so this is our function. So here we need to find k value, because here we have k value, right? So we need to find k value, and also second one is mean and third one is variance. Okay, so given that our function is f of x equal to kx e power minus lambda x, where x greater than or equal to 0 and comma lambda greater than 0, 0 otherwise. So here we are taking lambda is any parameter. So we should be focused on k value. So how to find the k value in probability density function? So we have one property. So that is by using the second property of probability density function, integration over minus infinity to infinity f of x dx equal to 1. So by using this formula, we have to find k value. Okay. So we know that by the total probability is unity, or by using the second property of probability density function, integration over minus infinity to infinity f of x dx equal to 1. Okay. So so here we have function, right? So that is f of x equal to k into x e power minus lambda x, comma x greater than or equal to 0. So that means x greater than or equal to 0 means, so here the value is 0 to infinity. Here the limits are 0 to infinity. So if the limits are 0 to infinity, the function is kx e power minus lambda x and 0 otherwise. That means infinity to minus infinity to 0. In that case, the function will be 0. So we have to split the limits. So minus infinity to infinity can be split into minus infinity to 0 and 0 to infinity. So that is minus infinity to 0 f of x dx plus 0 to infinity f of x dx. Okay. So but here we have function. Okay. So here we have function, but here the function will be 0. So in this case minus infinity to infinity to 0 case, the function is 0, and if the limits are 0 to infinity, the function will be kx e power minus lambda x. Okay, so this is 0 and this will be function. The function is there in this case. So minus 0 to infinity kx e power minus lambda x dx. The function is this one. Okay, so this is our function. Integration over 0 to infinity kx e power minus lambda x dx equal to 1. So you have to keep k outside. So k is a constant, you can keep in the outside, and so this will be in the form of UV method, right? So this will be in the form of UV method. So but we know that integration of UV equal to u v1 minus u dash v2, right? So integration of x e power minus lambda x dx equal to u x v1. So e power minus lambda x divided by minus lambda, because e power integration ax dx equal to integration of e power ax is e power ax by a. So like that so integration of e power minus ax dx is e power minus ax by minus a. So like that this will be, so integration of u v is, this is u, x is u, and e power minus lambda x is v. So this is u v1 minus u dash. So u value is, so here u equal to x, right? So differentiation of u dash is nothing but differentiation. So differentiation of x is 1. So that's why u dash is 1 and v2. So second differentiation. So e power minus lambda x divided by minus lambda. So thus that can be written as 1 by minus lambda, and e power minus lambda x differentiation is e power minus lambda x by minus lambda. Okay, so by using this one, that will be e power minus lambda x divided by lambda square. So e power minus lambda x divided by lambda square. So u v1 minus, this is u, x is u, and v is e power minus lambda x divided by minus lambda, and u dash is 1, x differentiation is 1, and e power minus lambda x second differentiation is e power minus lambda x divided by lambda square. Okay, so this is u v1, this will be in the form of u v1 minus u dash v2 according to our formula of uv. So if we simply, first of all we have to substitute upper limit and then lower limit. So first I am going to substituting upper limit. So k x e power minus lambda x divided by minus lambda minus 1 into e power minus lambda x divided by lambda square. So upper limit is 0, upper limit is infinity, and lower limit is 0. So first we have to substitute the upper limit. Okay, so here I am substituting upper limit first. So we know that because here if I substitute here, the function will be, old function will be infinity. So that's why I am substituting here. So otherwise you can apply L'Hospital rule. So but here I am substituting here in e power case. Okay, so here e power minus infinity. So e power anything is, e power minus infinity is, we know that 0, and e power infinity is infinity. E power 0 is 1 and e power minus 0 is also 1, right? So x into, so here I am substituting e power minus infinity. If e power minus infinity is 0 and 0 into anything is 0. So that's why first term is, I am substituting upper limit. Okay, first totally I am substituting upper limit, then lower limit. So here also I am substituting upper limit. So minus 1 into e power minus infinity. We know that e power minus infinity is 0. So 0 by anything is 0. First here I am substituting upper limit infinity. Okay, so e power minus infinity is 0. 0 into anything is 0. So here also e power minus infinity is 0 and 0 into anything is 0. So 0 minus 0 minus. So here I am substituting. So in this case e power. So here I am substituting first lower limit. So in place of x I am substituting 0, right? So 0 into anything is 0. Okay. So minus. So here I am substituting e power 0. So e power minus 0 by lambda square. So that means 1 by lambda square, right? Okay. So k into, so 0 minus 0 minus 0 minus into plus 1 by square. So 1 by square equal to 1. So from this k equal to lambda square. Okay. So this is k value. So like that we need to find mean of the distribution. So what is mean? So we know that the formula mean mu equal to So that is nothing but e of x equal to, so what is the formula? Integration over minus infinity to infinity x into f of x dx. So this is our formula, right? So integration over minus infinity to infinity x into f of x dx. So here I am splitting the limits according to our function. So what is our functions? Here we have function, that is, so f of x equal to k into x e power minus lambda x, where 0 to, the limits are 0 to infinity. So in minus infinity to 0 case, the function will be 0. Okay. So that's why, so here splitting the limits to minus infinity to 0 and 0 to infinity. Minus infinity to 0 and so here minus infinity to 0 x f of x dx plus 0 to infinity x f of x dx. So this is our function. So here I am splitting the limits into two cases, that is minus infinity to 0 and 0 to infinity. Okay. So here minus infinity to 0 case, the function will be 0, right? So according to this, minus infinity to 0, the function is 0, and only this case the function will be exist, right? So only in this case, this is 0 and 0 to infinity x into f of x. What is f of x here? So here f of x is x into k into x into e power minus lambda x. So that's why, so minus in 0 to infinity x into k into x into e power minus lambda x dx. So this is our function. So x into x is x square. So k into x square e power minus lambda x dx. Okay. So this will be 0, right? So now integrate this one. So integration of this one. So that means integration of 0 to infinity x square. K, you can keep k outside. Okay. So, but we know that what is k value? We know that k value is lambda square. So now I am substituting here lambda square. In place of k, I am substituting lambda square. So x square into e power minus lambda x dx. So let us consider this is u and this is v. So according to our formula, integration of uv equal to u v1 minus u dash v2 plus u double dash v3. Okay. So because here x square is there, so that's why I am writing up to second differentiation, because third differentiation will be 0. So that's why integration of uv, so that is u v1, u means x square, v1 integration of e power minus lambda x is e power minus lambda x divided by minus lambda minus u dash. So that is 2x, first differentiation, this is u, this is v1 minus this is u dash v2, second differentiation of this one. So that is e power minus lambda x divided by, already we have minus lambda, and e power minus lambda x differentiation is also minus lambda. So minus lambda into minus lambda, that is lambda square. So u v1 and u dash v2 is, so u dash v2 is this one, second integration. Okay. Plus u double dash v3. So 2 into, so differentiation of x. So here differentiation of x is 1. So that is u double dash v3. So third differentiation of v2. So how to write differentiation of v2? So differentiation of v2. So e power minus lambda x divided by, already we have lambda square, and e power minus lambda x integration is, sorry, e power minus lambda x integration is e power minus lambda x divided by minus lambda, because integration of e power minus ax dx is e power minus ax divided by minus a. So like that, e power minus lambda x integration is e power minus lambda x divided by minus lambda. So now that will be, so already we have lambda square and this is minus lambda. So that is minus lambda cube. Okay. So u v1, so x square into e power minus lambda x divided by minus lambda v1 minus u dash, differentiation of this one, differentiation of x square is 2x, and v2 integration of this one. So integration of v1 is, already we have e power minus lambda x e power minus lambda x divided by minus lambda, and the integration of e power minus lambda x, again we will get in the denominator minus lambda. So minus lambda into minus lambda, that will be lambda square. Okay, so next plus, this is minus. Okay, so next u double dash, differentiation of x, already we have 2, right? So this is 2, and differentiation of x is 1. Differentiation of x is 1. So u double dash is here 1, and v3. So integration of this one, integration of e power minus lambda x divided by lambda square. So already 1 by lambda square is there. E power minus lambda x divided by integration of e power minus lambda x is e power minus lambda x divided by minus lambda. So lambda square into minus lambda, that is lambda cube, minus lambda cube. So already, so this is minus lambda cube. Okay, so first of all we have to substitute upper limit. So this is minus lambda cube. Okay, so first I am substituting the upper limit. So upper limit is infinity is there. For upper limit we have infinity is there. So now I am substituting upper limit in e power minus lambda x in place of e power minus lambda x, that is e power minus infinity. But we know that e power minus infinity is 0, right? So e power minus infinity is 0, that's why this will be 0. So 0 into e power minus, here we will get e power minus infinity, right? Upper limit. For here I am substituting first upper limit, lambda square into upper limit. So here x square, I am substituting in e power place. So that's why that is e power minus infinity. If e power minus infinity is 0, so 0 into anything is 0. Okay, so minus. So here also I am substituting infinity. So e power minus infinity is 0. 0 into anything is 0. Okay, plus 2 into. So this is also 2 into something. So e power minus infinity. So e power minus lambda x, that's why that is e power minus infinity. We know that e power minus infinity is 0. Okay, so that is also 0. So this is also 0. So now if I am substituting infinity in all places of e power x, e power minus lambda x, the total value will be 0. So this is 0. E power minus infinity is 0. 0 into anything is 0. Okay, so that is 0. So e power minus infinity is 0. 0 into anything is 0. So e power minus infinity is 0. So upper limit is all 0. 0 minus 0 plus 0, right? So now I am substituting lower limit. Okay, so now I am substituting lower limit 0. So here I am substituting lower limit. Okay, so in place of x square I am substituting 0. Okay, so because if I substitute 0 here, so what is e power minus 0? So e power 0 is 1, right? So e power minus 0 is 1 by e power 0, that is 1 by 1, that is 1. Okay, so 1 into, already if I substitute 0 here, then 0 into anything is 0. So that's why simply I am substituting 0 here. So if I substitute 0 here, 0 into anything is 0. So this is upper limit minus lower limit. So lower limit is 0. So 0 into anything is 0 minus. So here also substituting 0. Okay, lower limit 0. So 0 into anything is 0 plus. So 2 into, so e power, so 2 into e power. Now here I am substituting 0. So we know that e power minus 0 is 1. So that's why 1 by minus lambda cube, right? So if I substitute this one, we will get 2 by lambda. Okay, so if I substitute all these values and simplify this one, we will get, so this is lambda square into minus plus, plus into minus, minus. So this is, already we have, this is minus, minus into minus plus, plus into minus, minus. Sorry. So this is minus, right? So lambda cube is there. So minus into minus plus. So that's why 2 by lambda cube. This will be. If I simplify this one, we will get minus into minus plus. So that's why 2 by lambda cube. So that is lambda, right? So 2 by lambda. So the answer is 2 by lambda. So like that we need to find the variance of the distribution or variance. So how to find the variance? So to find the variance we have formula. So always variance is denoted with lambda square. So that is equal to integration over minus infinity to infinity x square f of x dx minus mu square. So this is our actual formula. Okay. So now we have to split the limits into two cases. That is minus infinity to 0, 0 to infinity. So we have to split the limits into two cases. So that's why this can be written as minus infinity to 0 x square f of x dx plus 0 to infinity x square f of x dx minus mu square. Okay, so this can be written as integration over minus, in this case minus infinity to 0, in this case the function will be 0. So only this case the function will be exist. So that is x square. So what is f of x? So here f of x is k into x e power minus lambda x. K into x e power minus lambda x dx. So this is our function. So for this integration over 0 to infinity, so k, you can keep k outside. So x into x square, that is x cube e power minus lambda x dx. But we know that k value is lambda square. So now I am substituting k value here. That is lambda square into integration over 0 to infinity x cube e power minus lambda x dx. Now which will be in the form of integration of uv. So what is the formula for integration of uv? uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. Because here x cube term is there. That's why I am writing up to third differentiation u triple dash v4. So let us consider this is u and x cube is u and e power minus lambda x is v. Okay, so according to our formula uv1, so u is x cube and v1 is first integration e power minus lambda x by minus lambda minus u dash second first differentiation is x cube, differentiation is 3x square into e power minus lambda x divided by lambda square. Because already minus lambda is there, if I integrate e power minus lambda x again, we will get e power minus lambda x divided by minus lambda into minus lambda, that is lambda square, plus u double dash v3. So if I differentiate this one, we will get 6x. So if I integrate this one, we will get e power minus lambda x divided by minus lambda cube minus next differentiation. Next differentiation is u triple dash. U triple dash is 6 into minus x differentiation is 1. Okay. So and next integration is e power minus lambda x divided by lambda power 4. Okay. So this is the integration. Okay. So here upper limit is infinitive and lower limit is 0. Okay. Upper limit is infinity and lower limit is 0. So now I am substituting. We know that e power minus infinity is 0 and e power minus 0 is 1 and e power 0 is 1. Okay. So by using this concept we are finding the value, integration value. So first I am substituting infinity value. So always we have to substitute. If we have infinity, then we have to substitute in e power only. So then only we will get the correct solution. Otherwise you can use L hospital rule. Okay. So but here I am using the very simple method. So that is I am substituting infinity in e power. Okay. So e power minus, here we have e power minus lambda x. So e power minus lambda into infinity. So that is e power minus infinity. So we know that e power minus infinity is 0. Okay. E power minus infinity is 0. So 0 into anything, if I substitute minus infinity here, we will get this will be 0. Okay. So e power minus infinity is 0. So that's why this total term is 0. Okay. So the total term is 0. So now the 0 this is 0, right? So 0 into anything is 0. So already we have k value, right? So lambda square is there. Sorry. And we have, this is mu square. Okay, already we have discussed mu. So what is mu value? Mu is 2 by lambda. So don't forget this one. So mu is nothing but 2 by lambda. So here also we have mu square. Okay, mu square. This is also mu square. This is also mu square. So mu square is nothing but 2 by lambda. So that is 2 by lambda whole square. Okay, so now I am substituting upper limit first. So upper limit I am substituting in the e power. So e power minus infinity is 0. 0 into anything is, this is 0, and 0 into anything is 0. Okay, so minus 3x square. So but here I am substituting in e power place, I am substituting infinity. So e power minus infinity is 0, and 0 into anything is 0. Okay, so already we have lambda square, right? So first upper limit case. Okay, so this is 0 and this is also 0. Now this case. Okay, so now this case. So e power minus infinity, if I am substituting infinity here, now we will get e power minus infinity. So e power minus infinity is 0, and this is 0. 0 into anything is 0. So that's why plus 0 minus. So here also I am substituting e power minus infinity. So this is e power. Here also I am substituting infinity. So that's why this is e power minus infinity. E power minus infinity is 0, and 0 into anything is 0. Okay, so if I substitute infinity in the equation, okay, so we will get total term is 0. Upper limit is totally 0. So this is 0, minus this is 0, minus this, plus this is 0, and minus this is 0. Okay, so next lower limit. So lower limit is, what is our lower limit? Lower limit is 0, right? So if I substitute lower limit here, so this will be 0, right? So for upper limit I am substituting here, and for lower limit I am substituting here. You have to remember this one. Okay, so I am substituting a lower limit 0 here. So 0 into anything is 0, minus. So I am substituting 0 here. 0 into anything is 0. Plus I am substituting 0 here. 0 into anything is 0, minus. Minus 6 into, so I am substituting 0 here. So that is e power minus 0, right? So e power minus 0 is 1. Okay, so e power minus 0 is 1. So that's why that is 1 by lambda power 4. Okay, so this is minus, right? So minus into minus plus. So if I simplify this one, and we have mu square, right? So that is 2 by lambda whole square. Okay, so lambda square into, after this, so lambda square into this total value is 0, and this is 0, this is 0, this is 0, and minus is there, minus into minus plus. So that's why that is 1 by lambda square. Already we have 6 here, right? 6. Okay, minus mu square. So that is 2 square by lambda square. That is 4 by lambda square. Okay, so that is 6 by lambda square minus 4 by lambda square. So this is 6 by lambda square minus 4 by lambda square, that is 2 by lambda square. The total answer is variance of the distribution, or variance is here 2 by lambda square. Okay. Second problem. If f of x equal to k into e power minus modulus of x, minus modulus of x is a probability density function in the interval minus infinity less than x less than infinity, then find k value, and also mean, variance, and probability of 0 less than x less than 4. So given that the function is f of x equal to k into e power minus modulus of x. Okay, so we know that how to find k value. So by using probability density function, second property, that is integration over minus infinity to infinity f of x dx equal to 1. By using this formula, we can find k value. So that's why I am writing here. So integration over minus infinity to infinity f of x dx equal to 1. So what is our function? Our function f of x equal to k into e power minus modulus of x. So k into e power minus modulus of x. So k into, you can keep k outside, that will be k into integration over minus infinity to infinity e power minus modulus of x dx equal to 1. Okay, so but what is modulus of x? Okay, so what is modulus of x? We know that modulus of x equal to x where x greater than 0 and minus x where x less than 0. Okay, so x greater than 0 means, so modulus of x equal to x where x greater than 0 and minus x where x less than 0. X greater than 0 means 0 to infinity. X less than 0 means minus infinity to 0. Okay, so you have to remember this concept. Okay, so modulus of x equal to x where x greater than 0. X greater than 0 means the limits are 0 to infinity, and minus x, that means x less than 0, that means 0 to minus infinity, the limits are minus infinity to 0. So first of all, based on these limits, we have to split the limits. So we have to split the limits like this. So minus infinity to infinity can be splitted into minus infinity to 0 plus 0 to infinity. So minus infinity to 0 e power minus x dx and 0 to infinity e power minus modulus of x dx, that is equal to 1. So k into integration over minus infinity to 0 e power minus modulus of x. So minus modulus of x means where if the limits are minus infinity to 0, then the function will be e power minus x, right? So for this, so k into integration over minus infinity to 0 and e power minus of modulus of x is, so if the limits are minus infinity to 0, then the function is minus x. Already we have minus, right? Okay, so dx plus and 0 to infinity e power minus of modulus of x. 0 to in case of 0 to infinity limits, the function will be x. Okay, so this is our function. Okay, so k into integration over minus infinity to 0, this can be written as k into minus infinity to 0 e power minus of minus x, because modulus of x equal to minus x. Modulus of x equal to minus x where the limits are minus infinity to 0. The limits are minus infinity to 0 plus integration over 0 to infinity e power minus of modulus of x value is x, because the limits are 0 to infinity. If the limits are 0 to infinity, then modulus of x value is x. So that's why I am writing here x. Okay, so here the function is k into integration over minus infinity to 0 e power minus into minus plus x. So here I am writing, so k into integration over minus infinity to 0 e power minus into minus plus x dx plus integration over 0 to infinity e power minus x dx. Okay, so we have to simplify this one. So k into, so e power x integration is e power x. The limits are minus infinity to 0 and plus integration e power minus x integration is e power minus x by minus 1. So that means here we will get minus. Here we will get minus. So that's why these limits are 0 to infinity. 0 to infinity. So first here we have to substitute. So this is e power x differentiation is e power x or e power. So e power x limits are 0 to infinity and e power minus x by minus 1. So that is 0 to infinity. So I am writing minus 1 here. So I am taking minus outside. Okay. So for this, first I am substituting upper limit. So first I am substituting upper limit. So for this, k equal to first upper limit. So upper limit is e power 0 minus lower limit is e power minus infinity. Upper limit is minus infinity and lower limit is 0. Okay. So we know that k into e power 0 is 1, e power minus infinity is 0. Minus e power minus infinity is 0 and e power 0 is 1. Right. So that will be, so k into 1 plus 1. So that is k into 2. So k into, we will get 2. K into 2 equal to 1. So from this k equal to 1 by 2. K equal to 1 by 2. So like that we need to find mean. So what is the mean formula? Integration over minus infinity to infinity x into f of x. Okay, so that is equal to integration over minus infinity to infinity k into f of x. What is f of x here? F of x equal to, we know that f of x equal to k into x into e power minus of modulus of x. Sorry, k into e power modulus of x, not x. So k into e power modulus of k into e power minus modulus of x. Okay, so according to our modulus function, so modulus of x equal to x where x greater than 0, that means 0 to infinity. If the limits are 0 to infinity, the function is x. And modulus of x equal to minus x where x less than 0, that means minus infinity to 0 limits. In the case of minus infinity to 0 limits, the function is minus x. Okay, so that's why here I am splitting the limits. So k into, you can keep k outside, so and split the limits. Minus infinity to infinity can split it to minus infinity to 0 and 0 to infinity. Okay, so minus infinity to 0, x into e power minus modulus of x plus 0 to infinity x into e power minus modulus of x dx. Okay, so and e power minus infinity to 0 x into, so this can be written as k into integration over minus infinity to 0 x into e power minus of modulus of x where minus infinity to 0 limits, that will be minus x. So this is minus x dx plus integration over 0 to infinity x into e power minus of modulus of x where the limits are 0 to infinity. Where the limits are 0 to infinity, then modulus of x equal to x, that is dx. Okay, so this is our next step. So for this I am writing, so k into integration over minus infinity to 0 x e power minus into minus plus e power x, okay, dx plus 0 to infinity x into e power minus x. So our next step is this one. So minus into minus plus x dx plus integration over 0 to infinity x into e power minus dx minus x dx. Okay, so now this will be in the form of uv. So this is also in the form of uv. So we know that integration of uv is u v1 minus u dash v2. So this is u means x, u v1, first integration v1 minus u dash, x differentiation is 1 into v dash, so u dash v2. So second integration of e power x is also e power x. So that's why this will be x into e power x minus x. So like that, this will be also in the form of integration of uv, right? So u v1, so this is u is x. Okay, v1 integration of e power minus x, e power minus ax is e power minus ax by a. So like that, integration of e power minus x dx is e power minus x by minus 1. So integration of e power minus x is e power minus x by minus 1. Okay, that is v1, first integration, minus u dash, differentiation of x, that is x. So v2, so this one integration, so e power minus x by, already we have minus x, minus 1, and e power minus x integration is e power minus x by minus 1. Okay, so that will be, so minus into minus plus e power minus x by 1. Okay, so that's why this is e power minus x by 1. So this will be in the form of u v1 minus u dash v2. So here we have 1 into e power minus x by 1. So now I am substituting upper limit and lower limit. Here also upper limit and lower limit. Okay. So k into x e power x e power x minus x. x e power minus x, x e power minus x by minus 1 minus e power minus x by 1. So here the limits are minus infinity to 0. And here the limits are 0 to infinity. 0 to infinity. Okay. So this is our function, right? Before step. Okay. So now I am substituting upper limit. So k into upper limit. So upper limit is x, right? So that's why upper limit is 0. So that's why I am substituting here. So 0 into anything is 0. Minus e power 0 is 1. Minus. Okay. So lower limit. So for lower limit I am substituting here. So e power minus infinity is 0. 0 into anything is 0. Minus lower limit e power minus infinity is 0. Okay. So this is our first case. Okay. So next case is minus of. So first upper limit is infinity. If upper limit is infinity, we have to substitute in e power. Okay. So that's why e power minus infinity. So e power minus infinity is 0. 0 into anything is 0. Okay. Minus e power minus, if it is upper limit is infinity, that's why we have to substitute in the e power. So e power minus infinity, here I am substituting infinity. So that's why e power minus infinity is 0. Minus lower limit. So for lower limit I am substituting here. Okay. So this is 0. So 0 into anything is 0. Minus lower limit is e power minus 0. Okay. So for this, so k into minus e power 0, that is minus 1, plus, so this is 0, and this is minus into minus plus, and this is 1, right? So minus into minus plus, plus into minus, this is minus and minus, 1 minute. So already this is no, okay. So now I am substituting, I am simplifying this one. So this is minus 1 and this is minus into minus plus 1. So minus 1 plus 1, 0. So therefore the mean of the distribution, or the mean is 0. Okay. So next variance. For variance we have formula, that is integration over minus infinity to infinity x square f of x dx minus mu square. So integration over x square f of x. So what is f of x? K into, we know that f of x equal to k into e power minus modulus of x. Okay. So minus mu square. So k into, now I am splitting the limits because of this one. So modulus of x equal to x, where x greater than 0. That means 0 to infinity. So modulus of x equal to minus x, where x less than 0. That is minus infinity to 0. Okay. So for this I am splitting the limits. Okay. So that is k into minus infinity to 0 x square. So I am keeping the k outside. So x square e power minus modulus of x plus integration over 0 to infinity x square e power minus modulus of x dx minus mu square. So k into integration over minus infinity to 0 x square. So we know that. So here I am writing one more step here. So that is k into integration over minus infinity to 0 x square e power minus modulus of x equal to minus x, because here the limits are minus infinity to 0. Here the limits are minus infinity to 0. So that's why this is minus x dx minus. So integration over 0 to infinity x square e power minus of. So here the limits are 0 to infinity. So that's why modulus of x equal to x dx. So if we simplify this one, we will get this one. So that is k into integration over minus infinity to 0 x square e power x dx plus integration 0 to infinity x square e power minus x dx. And also we have minus mu square. So substitute. So let us consider this is u and this is v. This is u and this is v. Okay. So for this I am writing. So this will be in the form of k into x square e power x, integration over minus infinity to 0 x square e power x dx plus integration over 0 to infinity x square e power minus x dx. Okay. integration over minus infinity to x square e power minus x dx. So let us consider this is u and this is v. So here also same, this is u and this is v. So here we have x square, right? That's why uv, integration of uv equal to u v1 minus u dash v2 plus u double dash v3. Because x square term is there, that's why I am writing up to double dash. Okay, so this is u v1. So u x square. Directly here I am writing x square. v1 e power x differentiation is e power x minus u dash 2 in u dash x square differentiation is 2x. So that's why I am writing here 2x into v2. Next differentiation is e power x differentiation is, sorry, e power x integration is also e power x. Okay, so next 2x in differentiation u triple dash u double dash ux u 2x differentiation is 2, and next v3 e power x integration is e power x. Okay, so this will be in the form of u v1 minus u dash v2 plus u double dash v3. Okay, so like that here also same, u is x square, v1 e power minus x, integration of e power minus x dx is e power minus x by minus 1. So v1, so this is first integration, minus second differentiation. So that is u dash minus u dash v2. So this is our second integration, e power minus x divided by minus 1, and e power minus x integration is e power minus x by minus 1. So minus 1 into minus 1, that will be plus 1. Okay, plus u double dash. So 2x differentiation is 2. Next v3. So this one integration. So e power minus x divided by 1 is there. So this one integration is e power minus x by minus 1. Okay, so now I am substituting upper limit and lower limit. So now here I am substituting upper limit. So always if the limit is 0, then you can substitute in place of x. If the limit is infinity, you can substitute that limit in e power. Okay, so here I am having 0. Okay, so 0 I am substituting here. Otherwise you can use L hospital rule. So here upper limit is 0, so that's why I am substituting 0 here. Okay, so 0 into anything is 0. So k into 0 into anything is 0, minus, in this case here also I am substituting 0 here, upper limit. So that is 0 plus, but here we don't have x value. Okay, directly you can substitute in the e power. Okay, so that is 2 into e power 0. Okay, minus lower limit. So for this lower limit is minus infinity. So if infinity or minus infinity is there, you can substitute in e power. So e power minus infinity is 0. That's why this will be 0, minus 0. That's why that will be 0. And here also e power minus infinity is 0. That's why 0, e power minus infinity is 0. 0 into anything is 0. Plus e power minus infinity is 0. 0 into anything is 0. So that's why, and we know that into e power minus infinity is 0 and e power 0 is 1. So that's why this will be total value is 2, right? So the total value is 2 in this case. In this case, upper limit and lower limit values, total value is 2. And the next one is, so integration of, if I am substituting infinity, so infinity we have to substitute always here, right? So e power minus infinity is 0. 0 into anything is 0. Okay, so minus, first this is upper limit. So e power minus infinity is 0. 0 into anything is 0. Plus 2 into e power minus infinity is 0. 0 into anything is 0. Minus lower limit. So lower limit, for lower limit I am substituting here. Okay, so otherwise we can use L hospital rule. Okay, so this is 0. 0 into anything is 0. Minus this is 0. Plus 2 into, we don't have here x. So that's why here I am substituting e power minus 0. So that is 1. So minus into minus, plus 2 is there. So 2 plus 2, that is 4. So k into 4 minus, already we have mu square, right? So we have mu square. So what is mu value? mean mu equal to 0. So that's why I am substituting here 0. Okay, so mu square value is 0. That's why this is 0 square. So k into 4 minus 0. So that is k. We know that k value. So what is k value? K value is 1 by 2, right? So here k value is 1 by 2 into 4. That is 2. So variance is 2. And also we have one more question. So that is probability of 0 less than x less than 4. So according to this formula, probability of a less than x less than b, the formula is integration over a to b f of x dx. So that's why integration probability of 0 less than x less than 4, that is equal to 0 to infinity f of x dx. So what is f of x? F of x is x into e power minus modulus of x. 0 to 4 k into e power minus x minus modulus of x dx. So we know that mod x equal to x where x greater than 0, that means 0 to infinity, and modulus of x mod x equal to minus x where x less than 0, that means minus infinity to 0. Okay, so k into integration over 0 to infinity. So if I substitute integration over 0 to infinity, k you can keep k outside and e power minus of. So here the limits are positive, right? So that's why we have to take this one. So modulus of x equal to, so here the modulus of x equal to x dx. So that's why I am taking this one. So k into integration over 0 to infinity e power minus x dx. So we know that integration of e power minus x is e power minus x divided by minus 1. So here the upper limit is 4 and lower limit is 0. So if I substitute upper limit first, so e power, that is minus 4 by minus 1 minus lower limit. So e power minus 4, e power minus 0 divided by minus 1. So e power minus 4. And so here also we have minus 1, here also we have minus 1. Taking the minus common, so that is minus k. And what about this one? So this is e power minus 4 and e power 0 is 1, and we know that e power minus 0 is also 1. So that's why this is 1. So therefore if I simplify k, we know that k is 1 by 2, right? So already we have solved this one. So k is 1 by 2. So if I substitute k value here, we will get the solution like this. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.